So as I told before, today I will explain the hemostasis process, and in that hemostasis process, our complete blood lecture, the lecture of the blood portion will complete it. So now we have to know about the hemostasis. So what is the meaning by the hemostasis? So if any injury happens, like to stop the bleeding at the injury site, it needs that the physiological process, that is the hemostasis. So cessation of the bleeding from a blood vessel, you can write down. And this process involves the multiple interlinked steps. So first of all, we have to know about what are the steps. So primary hemostasis, where another is the secondary hemostasis. So in primary hemostasis, what happened? The platelet aggregation and platelet plaque formation. Platelet aggregation and platelet plaque formation. So platelet aggregate and the platelet plaque formation. So platelets are activated by the multi-phase process. I'll explain what is the intrinsic factor and the extrinsic factor. So how platelet get activated and make it. So that is the platelet aggregation and platelet plaque formation. And in secondary hemostasis, it is like the insoluble fibrins are there. So like soluble to the insoluble fibrin, how it is made. Okay, so let's write down one word: deposition of insoluble fibrin. So four important steps are essential for if any cut is there. I am writing down that four process, and then I will explain the how this four process occur in complete depth. So first I have written down that these are the process is there. Like first process, it needs the vasoconstriction. And B, the second process, the platelet plaque formation. And C, it's clot formation. And D is the clot removal. So this is the four method is essential for the hemostasis process. So what are the purpose? The hemostasis facilitates a series of enzymatic activations that lead to the formation of the clot with the platelets and fibrin polymer. The clot seals the injured area, control and prevents further bleeding while the tissue regenerates. So once injury starts to heal, the plaque slowly removes and then it dissolves the restorations of the normal tissue at the site of the damage. So this is the basic physiological status of hemostasis. Now we are going to the vasoconstriction. So what happened in the vasoconstriction? Like within the 30 minutes, their damage or trauma blood vessel, their vascular spasm ensures. What is the vascular spasm? So you can see if injury is there, the site of the injury is there. So in that site of the injury, their reflex of the vasoconstriction is there. So that means these are the endothelial cells. So these are the endothelial cells. So these cells release one common protein that is called endothelin. So that helps this endothelin releasing there in that section. So these ECM collagen get constricted and they move towards the wound site and it is automatically constricted. So at the disturbed endothelial lining, the ECM or collagen become exposed to the blood components, and due to its, so collagen or ECM, and due to its, it gets constricted. So like this is the blood vessel, this is the injury site, so it like constrict. So okay, so this is the basic process of the vasoconstriction. So then now the platelet plaque. So before platelet plaque, one process is there that is called the platelet adhesion. What is the platelet adhesion? So ECM, that is the extracellular matrix. In this region, these are the extracellular matrix that release the different kinds of cytokines and inflammatory markers. I'll coming through that. So these are kind of integrins that binding with the circulating platelets, and then platelet will come here. So before coming, it needs to the activate there, and then at the leading side, the formation of the platelet plaque sealing that defect. So in that, this is a defect region, platelets are coming there and make a plaque on that region. So von Willebrand factor binding to the GP1V9 within the platelets. So platelet adhesion, that process mediated by the interaction between the various receptors and the proteins, including the tyrosine kinase receptor, glycoprotein receptor, and different kinds of G protein receptors. So that is the factor, von Willebrand factor, that binding to the GP1B9 within the platelet. So now platelet is activated. Like you can think about the charge, it's like more overcharged. Like now platelet is ready for that adhesion portion. So in that injury site, one protein, specific protein, its name is thromboxane A2. Thromboxane A2 is released. So this is also release the serotonin. Thromboxane A2, serotonin activated. So platelet attached with the damaged cell, and then it is released the ADP, and then platelet is completely activated. Completely activated. So now let ADP. So these ADP acts as chemoattractant of platelets. Damage endothelial cell, then start expressing integrin, Willebrand factor binding with the receptor of the platelet, like GP1B9, GB1B9 receptor of the platelet receptor. Now it is platelet is activated, completely activated the platelet. Now platelets bind with that damaged cell, bind the damaged cell, like bind the damaged cell, then secretes the ADP, thromboxinase A2, thromboxine A2, and if thromboxane A2 is there, and then it forms the plaque. Platelet plaque. So that is the, I think this is a very light color. I should change the color. Okay. Top slide, vasoconstriction and platelet plaque formation is there. Now the C step is the clot formation. Now written down the clot. How clot will form? Like that means the platelets are there. Now platelet will making the clot. So how clot will be there? So like first, our main key element is platelet plus another important element is the fibrin. Fibrin need the some mesh work like structure, like this is kind of cross linking, So this is the maze like structure. It needs the some of the cross linking in nature. So fibrin maze work is needed. So like for clot formation, platelets plus fibrin maze, and that make the clot. Okay. So platelet and fibrin maze. Now how the fibrin is soluble in that blood. So how the fibrin is coming from the maze work? So it needs the insoluble one. So how fibrin is insoluble? They are coming from the fibrinogen to the fibrin. So just written down, the soluble form is the fibrinogen. It's a soluble. It's called the proteolytic phase. So that means fibrins, some of the active sites are not active. After cleavage, these sites are just kind of open. That is called the proteolytic. In that time, another factor come. Okay, so that is the known as thrombin. So thrombin come in that specific process and make the fibrin. So fibrin, and at that time it's need the some cross linker. So what will be the cross linker? Maze work, I have already written down the maze work. So maze, or for maze, it's need the factor 13. I'll explain every factors in the intrinsic and extrinsic pathway. I'll explain all the factors. Now we just written down their factor 13, which is the acts as a cross linker. So that means this fibrin and fibrin coming to that region. So platelet and plaque, so that is a clot. Now it's a clot stabilized, and we have to know where thrombin is coming. Thrombin is coming from the another protein, that is the prothrombin. Prothrombin. So prothrombin to thrombin, that way we need the extrinsic pathway. Number 2, the intrinsic pathway. Extrinsic and need the intrinsic pathway. So prothrombin to thrombin. So like fibrinogen, this is the soluble fibrinogen. Now we have to know about the different structure of the fibrinogen. So this is the total clot formation. So in that clot formation, I will just make the summary on that. So platelet is already activated by von Willebrand factor, and the ADP is released. ATP is like a, already I have written down what is the ADP's role. ADP is like binding like thromboxane. It's acting as a chemoattractant for that platelets. So already platelet come and activated in that region, and in another way the prothrombin to thrombin made by extrinsic or intrinsic pathway, and fibrinogen soluble in the blood. Fibrinogens bind and its active region is opened. The thrombin and fibrinogen bind and make the fibrin. At that time, the factor 13 comes, that is the kind of cross-linking element, and make the fibrin maze work. In fibrin maze work, their platelets are getting stored. Like fibrin maze work and platelets getting stuck. So it make that the clot. So in very brief, I'll go through the prothrombin structure. In prothrombin, like their alpha subunit, A alpha, B beta, and gamma. And its fibrinogen, it's formed like a dimer of the dimer molecule. That means A alpha, just written down, A alpha, B beta, and gamma. This is the structure of the fibrinogen. There is a 2 subunit. When it is in the prothrombin structure, it is like disulfide bond is linked on that. So like 2 pairs, 2 pair. That kind of structure is there. So when prothrombin to, so I'll go through, if needed I'll go through the complete details of the prothrombin, and then I'll go to the thrombin. Now I'll discuss the 13th factor, and then I'll go for the intrinsic and extrinsic pathway. So before going to the intrinsic and extrinsic pathway, we need to know one important factor, that is the vitamin K, and this is the synthesized in liver, and it helps to the thrombin in circulating the blood, thrombin. Okay. Fine. So now I'll explain the what are the 13 factors that help the prothrombin to thrombin region. Prothrombin to thrombin, it helps. Okay, let's write down. So our main targeted factor is the factor 1, that is the fibrinogen. I'm writing down fibrinogen. So fibrinogen, then a factor 1, factor 2, it will be like prothrombin. Factor 3, is thromboplastin. Factor 4, thromboplastin is a extrinsic factor, that's why I'm just writing down. Factor 4 is the, we all know, calcium ion, it's in all. Factor 5, from this we have to just recall this name, it is called the labile factor. So in factor 5 also it has another name, that is called the pro-accelerating function. Pro-accelerating. And factor 7, so 1 2 3 4 5 7, 7 is known as the factor of SPCA. What is the SPCA? SPCA is the serum prothrombin conversion acceleration. Serum prothrombin acceleration, conversion acceleration. So that means you can get that name. So that is called the pro-converting. So that is the pro-converting SPCA. Now we go for the factor 8, that is essential for disease purpose, that is called anti-hemophilic factor, or abbreviation AHF, anti-hemophilic factor. I'll discuss details about the AHF in another video or in different class, whether I can cover the hemophilic disease and all those things. That is the essential element, AHF. And in 9, factor is the PTC, that means plasma thromboplastin component. It is also known as Christmas factor, because the another disease, Christmas factor. Factor 10, that is called the Stuart factor. Stuart, Stuart factor. Like they are, this is extrinsic and intrinsic, both the pathway in the factor 10 is involved. Okay, now written down. Factor 11, it will be the PTA factor. Why PTA? Plasma thromboplastin antecedent factor. So the 9th is the PTC factor, plasma thromboplastin component, and this is the plasma thromboplastin antecedent component, that is the anti-hemophilic factor C. Anti-hemophilic factor C. Hope you can understand. Anti-hemophilic factor C. Now the factor 12, known as the Heisman factor. Heisman, is factor 12 is Heisman factor, or it is known as glass factor. Now factor 13, that is the FSF. It acts like a cross-linker, that is fibrin stabilizing factor, because it acts as a cross-linker, so that's why it's a fibrin stabilizing factor. It's a fibrin stabilizing factor. Also, it had another name. It's called Locke-Leonard factor. Locke, L-O-R-A-N-D. Locke-Laurent factor. So this is the 13th factor involved with that prothrombin to thrombin process. So already I have mentioned that the prothrombin to thrombin process, it needs the different kinds of factors to make that the fibrinogen bind into the thrombin process, and it helps the platelet, there's a clot formation. So for that it's needed. Now I'll go into the intrinsic pathway and extrinsic pathway. Intrinsic pathway, like it's a clotting factor present already in the blood, so that's why damage occur. Collagen fiber exposed, so like collagen fiber is like exposed, and that's why this factor, intrinsic factor, like the vessel damage or expose the collagen. So like you can write down the intrinsic pathway. I'm just abbreviating with intrinsic pathway. So in that pathway first happen the collagen, yeah, if collagen damage, it's going to the contact activation. So collagen damage, it's going to the contact activation, and that from the 12 inactivate to 12 active. So collagen damage, contact activation, 12 inactive to 12 active, and this 12 active that help the 11 inactive to 11 active. So what happened? If 11 is active, then 9 inactive to 9 active. So you write down, it will easily remind 12, 11, 9. And then if 9 is activated, so it's the activated region, then it's bind to the calcium ion. So factor 4, calcium plus plus. So calcium is coming, and then this is, and it helps the 10 inactivated to 10 activated. So like in that process, another important factor is factor 5. So factor 8 is coming, and calcium ion, and then the class 10 to 10 inactivate to 10 activate, and this 10 activate, if 10 is activated, then the factor 5 is activated, and it all make the prothrombin to thrombin. Prothrombin to thrombin. Okay, so hope you can understand. So it is the intrinsic pathway. In the extrinsic pathway, I'll go next slide. Go for the extrinsic pathway. So it's like if the tissue is damaged, so then the tissue factor is coming, the damage of the tissue factor, and then is called factor 7. So tissue damage and factor 7. So what happened? This the factor 7. It's directly coming to the 9, to the 9A, and then same type of things. Factor 5, calcium ion, it's coming, and then the 10 to the 10A, and then 10A along with calcium ion still needed, and then the prothrombin to thrombin. And the step for stabilizing, it's need the 13 factor 13 inactivate to 13 activate, and if it is there, then the clot is stabilized. Clot is stabilized. Hope that every factor I have already discussed all the factor and their name. Now we have to know about the clot removal process. So how the removal process is going on, and this is I'll just explain it very briefly. because the video is too long. So newly from endothelial cells already fill the gap, like this is the vessels. So already, let's say this is a zone, new endothelial cells already coming. Writing down new endothelial cells already come, and then start releasing they release the tissue plasminogen activator. Tissue plasminogen tissue plasminogen activator. So this is already trapped in the blood clot. So that means this can change the plasminogen to plasmin. So that is called the plasminogen to plasmin. And this plasmin help the clot to dissolve. Okay, now plasmin present in the normal blood. So it's present in normal blood. So now that is the process of clot removal. So the process of clot removal. Hope that everyone is understand about the whole process of hemostasis, and I'm trying to make it very brief. And although I want to discuss some of the TFPI, the tissue factor pathway inhibitors, some of the inhibitors are there. Along with, I want to discuss some more details on that, like the protein C and thrombin combination in the endothelial cell, and how the activated protein C that the stimulated to the factor 8A activated by that factor. Also, I want to discuss more, but still, okay, fine. These are the important aspects of that. So also, I'll just discuss some anti-clotting drugs are there, like aspirin, heparin. These drugs are commonly used as a anti-clotting factor. Like the aspirin, it is the effective to prevent and rescuing the heart attack. Upon the immediate administration, it inhibits the platelet aggregation, important for the coagulation by inhibiting the cyclooxygenase enzyme and generate the prostaglandin and thromboxanase. Also, you known about the thromboxanase A2, the role of the thromboxanase A2 and prostaglandin already we have discussed that. And heparin, it's a natural cofactor for the antithrombin 3 that can administer as a drug, and it can additionally inhibit the platelet function. So these are the anti-clotting drugs that already used as a medicine, and some of the oral anticoagulants is there for that, responsible of the vitamin K. Vitamin K's are there, and some of the conditions which lead to the excessive bleeding, like the vitamin K deficiency, hemophilia. These are the condition, or their thrombocytopenia. Where in thrombocytopenia, what happened due to the low number of the platelets, small puncture of hemorrhage occur throughout the body. Even a given characteristic of small patches are there.